Today we're going to learn about Python sets, one of the most useful data types that beginners often skip over. A set is a collection that stores unique values only. Duplicates are automatically removed the moment you put them in. Here's what that looks like in code. We create a set with the values 1, 2, 3, 2, and 1. 2 duplicates in there. When we print it, we get back just 1, 2, and 3. Python removed the duplicates automatically. You didn't write any extra logic. You didn't loop through anything. The set handled it for you. Now that you know what a set is, let's look at how to actually create one in Python. The first way is with curly braces. You write the variable name, an equal sign, then your values inside curly braces separated by commas. That gives you a set of strings, apple and mango. The second way is with the set constructor. You write set with parentheses and pass a list inside it. Both methods give you the same result, a set with unique values. Now here is something that trips up almost every beginner. If you write empty curly braces with nothing inside, Python does not give you an empty set. It gives you an empty dictionary. To get an empty set, you must use set with nothing inside the parentheses. Good. Now you know how to create a set. But before we use one, let's understand how it actually behaves, because sets have 3 characteristics that make them very different from lists and tuples. First, no guaranteed order. Items in a set have no fixed position. Python can print them in any order, and it may not match the order you type them in. Second, no duplicates. Every value in a set is unique. Add the same item twice, and it only appears once. The set just keeps one copy. Here is both in action. We create a set with 3, 1, 2, 2, 3 duplicates and a scrambled order. The output is 1, 2, 3, clean, unique, and in whatever order Python chose. Third, no indexing. If you try to access a set item by position, like s at index 0, Python throws a type error. Sets have no positions. There is no first item or no last item, just a collection of unique values. Now let's look at the methods that let you change what's inside a set. There are 4 main methods, and we'll go through each one individually. We start with add. Add is how you put a new item into a set. You call add and pass one item inside the parentheses. Start with a set containing 1, 2, and 3. When you call s.add4, Python checks whether 4 is already in the set. It is not. So 4 gets added. The output set now has 1, 2, 3, and 4. Now, what if you call s.add2? Python checks 2 is already there. Nothing happens.
No error, no duplicat.
The set stays exactly as it was. That is the add method. One item in, and duplicates are silently ignored. Now, let's look at a method that takes things out, remove. You call remove and pass the item you want to delete. Start with the set 1, 2, and 3. Notice that 2 is highlighted. That is the item we are targeting. When you call s.remove2, Python finds it and takes it out. The output set is now just 1 and 3. But here is the danger. If you try to remove an item that is not in the set, like 9, Python raises a key. Your program stops right there and crashes. So always use remove only when you are certain the item exists in the set. Remove works, but it crashes if the item isn't there. What if you're not sure? That's exactly what discard is for. Discard looks just like remove, but it behaves differently when the item is missing. In the first scenario, the item is already in the set. We have the set 1, 2, and 3. When we call s.discard2, Python finds it and removes it. The output is 1 and 3. Same as remove so far. In the second scenario, the item is not in the set at all. Same set, but this time we call s.discard9. 9 is not in the set at all. With remove, this would crash. With discard, Python just does nothing.
No error, no crash.
The set stays exactly as it was. That is the key difference. Think of discard as the safe version of remove. Use it whenever you are not sure if the item is there. The last method is the most drastic one. It is called clear. Unlike the other methods, it does not remove one item. It removes every single item at once. You call it with no arguments. Nothing goes inside the parentheses. Let's start with the set 1, 2, and 3. When you call s.clear, every single item is removed. The output set is completely empty. Here is something important to know. Clear does not delete the variable s. It just empties it. The variable s still exists after this line. You can keep using it. Add new items to it. Check its length, anything you want. We've covered how to create sets and how to modify them. Now let's look at something really powerful. What happens when you have two sets and want to combine or compare them? Sets support 3 operations for this. Let's use 2 sets. Set A contains 1, 2, and 3. Set B contains 3, 4, and 5. Notice that 3 is in both sets. That shared item is key to understanding all 3 operations. The first operation is union. You use the pipe symbol between 2 sets. The result is every item from both sets combined. So set a union set B gives us 1, 2, 3, 4, and 5. Notice 3 appears only once, because sets never keep duplicates. The second is intersection. You use the ampersand symbol. This gives you only the items that appear in both sets. Since only 3 is shared, the result is just 3. The third is difference. You use the minus symbol. This gives you items that are in set A, but not in set B. So 3, 4, and 5 are excluded because they belong to B. What remains is just 1 and 2. Sets handle duplicates automatically in every operation. You never have to clean them up yourself. You now know what sets are, how to create them, their characteristics, all 4 methods, and how to combine them. The last question is this: when should you actually reach for a set in real code? Here are 3 situations where sets are the perfect tool. The first is removing duplicates from a list. Say you have a list of names with Alice and Bob appearing twice. Wrap it in set to strip the duplicates, then wrap that in list to convert back. 1 line, job done. The second is fast membership testing. If you need to check whether an item exists in a collection, sets are the fastest option in Python. Checking whether Jim is in a set of visited places returns true instantly, even if the set has millions of items. A list would have to scan one by one. The third is comparing 2 groups. If you have one set of Python developers and another of JavaScript developers, a single ampersand gives you the people in both groups. No loops, no manual comparison. The rule of thumb is simple. Reach for a set when uniqueness matters, order doesn't, and speed is important. That's Python sets. Thanks for watching. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.